At 1:10 local time, a convoy of 120 Russian fuel tankers was moving from Rostov through Mariupol toward Crimea. Disguised as civilian trucks carrying milk and clean water, the convoy's commander believed the camouflage would ensure a safe journey. What the Russians did not know was that Ukraine had already mapped the entire route. High above a lead, 100 reconnaissance UAV silently tracked the convoy. Its optical camera spotted a damaged bridge ahead where the road narrowed, forcing the fuel trucks to slow down and bunch together. It was the perfect choke point. The convoy carried more than 10,000 tons of fuel, the lifeline sustaining Russian bases, armored vehicles, and air defense systems across Crimea. Everything appeared to be unfolding exactly as planned, but within 3 minutes, the Ukrainian UAV became the hunted. Every video transmission exposed electromagnetic emissions that Russia's electronic reconnaissance network began detecting. At first, the signal seemed random, but repeated transmissions from the same area quickly revealed that a Ukrainian surveillance drone was operating nearby. As the convoy continued toward the bridge at 25 miles per hour, now only 3 miles from the ambush point, the Ukrainian strike team prepared to launch 45 attack UAVs. Yet 3 layers of Russian defenses already stood between them and their target. Among the most dangerous was the Yastreb AV counter-battery radar. The system continuously monitored the airspace, recording every UAV transmit. Each signal added another bearing line, and as multiple lines intersected, the Russians steadily narrowed down the location of the Ukrainian operators. The intersecting signal lines led Russian forces directly to the Ukrainian UAV control team. Just 2 minutes later, artillery shells slammed into their position. The operators quickly realized their mistake. They had been transmitting from the same location for over 5 minutes, allowing Russia's Yastreb AV system to calculate their coordinates and direct artillery fire with deadly precision. After the barrage, the team stopped continuous video transmission. Instead, the Li 100 reconnaissance UAV switched to AI-powered autonomous mode, independently tracking the Russian fuel convoy while drastically reducing its electronic signature. Yastreb AV immediately lost the steady signal it needed to continue tracking the operator. Moments later, a Russian Orlan 30 reconnaissance drone arrived to search the area with thermal cameras. Facing detection, the Ukrainian team shut down equipment, concealed batteries and transmitters, and hid beneath thermal blankets, disappearing from infrared view. Before going silent, however, the LEA 100 transmitted one final encrypted data burst lasting only 0.5 seconds. The packet contained the convoy's GPS coordinates, speed, wind conditions, and the optimal attack timing. Sent over an unexpected frequency, it was too brief for Russian electronic warfare systems to locate or decode. 3 miles away, the Ukrainian FP-1 strike team received the complete targeting package. Ahead, a damaged bridge had forced all 120 Russian fuel tankers into a single slow-moving column. Crawling across the damaged roadway at just 6 miles per hour, the section carrying nearly 1,000 tons of fuel had become the perfect target for the incoming FP-1 drones. If a single fuel tanker was destroyed in the middle of the bridge, the blast could ignite the vehicles ahead and behind it, turning the narrow crossing into a chain of explosions. But Ukraine had only 8 minutes before the convoy cleared the bridge and regained normal spacing. At exactly 1:35 local time, the Ukrainian strike team launched the first FP-1 drones. Each UAV used a 10-inch carbon fiber frame, carried a 7-pound shaped charge warhead, and had enough battery for about 7 minutes of flight. The bridge was only 5 minutes away, but the drones first had to penetrate 3 layers of Russian defenses. The first obstacle was electronic warfare. Russian forces understood that destroying the drone was unnecessary. If they could sever the link between the UAV and its operator, the mission would fail before the FP-1S even reached the target. For the first mile, everything went according to plan. Flying just 6 feet above the ground, the FP-1 drones used tree lines, roadside embankments, and ruined buildings to stay hidden. Their cameras streamed 1080p video at 60 frames per second, giving operators a clear view of every obstacle ahead. But traveling with the convoy was a Crimea truck equipped with the R330 ZTEL electronic warfare system. Rather than connecting communications, Zhitel flooded the battlefield with powerful electronic noise jamming, GPS, GSM, and the frequencies commonly used to control UAVs. The FP1 signals were still being transmitted, but they were buried beneath the interference. The video feed immediately began to deteriorate. The image shook, interference lines appeared, and the frame rate dropped from 60 to 30, then to just 15 frames per second, making the picture barely usable. Even so, the FP1 drones did not remain on a single control frequency. The FP1 drones immediately began frequency hopping across 124 channels, switching into non-standard bands that the Russian R-330 Zhitel system was not optimized to jam. Although the signal became delayed and unstable, it remained strong enough for the operators to guide the drones until they were less than a mile from the bridge. As the formation entered the heart of the jamming zone, Zhitel increased its power. The video froze, broke into blocks of interference, and finally disappeared. Under normal circumstances, the mission would have failed. But the FP1S carried an AI-based vision system. The moment contact with the operators was lost, onboard computer vision took over. The AI analyzed camera images, searching for the bridge, fuel tankers, and the tightly packed convoy. Once the target was identified, it locked onto the tanker positioned near the center of the bridge and continued the attack without further commands. Zhitel could jam communications, but it could not stop a decision already stored inside the drone. From that point forward, the FP1 had to fly through the electronic interference, relocate the bridge, and keep the target in view long enough for the AI to maintain its lock. The operators no longer controlled the strike. Their screens displayed only flight data: altitude, 6 feet, speed, 28 miles per hour, and a steady compass heading toward the bridge. The video signal occasionally flashed back for 1 or 2 frames before disappearing again. Those brief images proved critical. In one frame, the operators spotted roadside markers and estimated the bridge was about 1.5 miles away, with the convoy roughly 1 mile ahead. They corrected the drone's heading using the compass and pushed the FP1 swarm another 500 yards through the electronic storm. Just 5 seconds later, the video feed suddenly returned. The FPV swarm had passed through the strongest jamming zone, but the formation had been pushed to the right of its original flight path. The bridge appeared on the left edge of the screen, while the fuel convoy was still slowly crawling across the damaged deck. The AI began identifying the target. But in that same frame, Russian interceptor UAVs at an altitude of 75 feet were diving down from above the tree line. The Russian interceptor UAVs dived in at a 60-degree approach angle. They carried no warheads, allowing them to maneuver more freely. Their only mission was to create an impact powerful enough to detonate the 7 pounds explosive charge carried by the enemy drone. The Ukrainian FPVs used 10-inch carbon fiber frames, but the shaped charge warhead sharply increased the total weight of the system. After nearly 4 minutes of continuous flight, the batteries had begun to sag, while the motors had to maintain heavy thrust just to hold an altitude of 6 feet. They could still fly straight at 80 miles per hour, but they no longer had enough power for sudden acceleration or sharp evasive turns. By contrast, the Russian interceptor UAVs carried no explosives, making them lighter and giving them a higher thrust-tow ratio. From an altitude of 75 feet, they dived and accelerated, at the same time converting altitude into speed. 2 Russian UAVs accelerated to 120 miles per hour. The Ukrainian FPVs were still racing forward at around 65 miles per hour. The combined closing speed exceeded 180 miles per hour, or more than 260 feet per second. At a range of 500 yards, the Ukrainian team had less than 6 seconds to react. The operator tried to break the formation to both sides, but the warhead-laden FPVs responded more slowly than expected. Inertia kept pulling them forward, while the batteries no longer had enough output to push the motors to maximum power. At 100-yard impact was less than 1 second away. The 2 Russian interceptor UAVs slammed head-on into the 2 lead FPVs. The first collision struck the forward frame and triggered the 7-pound shaped charge warhead. A fireball erupted at an altitude of 20 feet, tearing the FPV into hundreds of fragments of carbon fiber and metal. But those 2 explosions revealed the pattern behind the Russian attack. The interceptor UAVs had to dive at extremely high speed, and once they committed to the dive, that phase became final. Either they hit the target or they crashed into the ground. And the Ukrainians realized that the 7-pound warhead was not only a disadvantage, it could also pull the FPV downward faster. The second interceptor group appeared at a distance of 400 yards. They began their dive accelerated to 120 miles per hour and aimed straight at the next two FPVs. At 250 yards, the Ukrainian operators did not try to turn left or right. They waited. The distance dropped to 150 yards. Just over 1 second remained before impact. Right as the Russian UAVs locked into their dive path, the Ukrainian operators suddenly cut the motors completely. Lift vanished. Under the weight of the warhead, the FPVs instantly dropped nearly 15 feet in less than 1 second, falling out of the collision path vertically. The Russian UAVs tore through the space where their targets had been a moment earlier. At more than 110 miles per hour and only about 25 feet above the ground, they no longer had enough turning radius to pull up. One slammed straight into the roadside embankment and shattered into pieces. The other buried itself in the dirt beside the road and lay motionless. But the sudden throttle cut also pushed the Ukrainian FPVs into a dangerous position. Once thrust disappeared, they were no longer aircraft. They became heavy blocks of carbon fiber falling freely through the air. If the operator increased throttle too aggressively, the sudden torque could flip the UAV sideways. But if the reaction came even 1 second too late, they would slam straight into the ground. Fortunately, the Ukrainian crews had practiced this maneuver dozens of times on the training range. They did not push the throttle to maximum. Power was increased slowly, step by step, just enough for the propellers to regain lift. The FPVs wobbled violently, then stopped their fall at an altitude of 8 feet, but the Russians still refused to give up. A third group of interceptor UAVs appeared above the tree line, once again taking altitude and preparing for another dive. This time, the Ukrainian operators understood that if they kept reacting passively, each FPV would be hunted down one by one until none of them reached the bridge. So they decided to set the trap first. The FPV swarm immediately split into two groups. The first group suddenly accelerated to 120 miles per hour, charging straight toward the convoy as if beginning the final attack phase. The move instantly drew the entire Russian interceptor group. They banked, accelerated, and chased the targets flying higher above the ground. Meanwhile, the second group slowed down and gradually dropped to an altitude of only 3 feet. From the Russian perspective, they looked like UAVs with dying batteries, broken formation, and no remaining ability to continue the attack. The trap worked. The Russian UAVs ignored the low-flying group and pushed all their speed into chasing the FPVs racing toward the bridge. But to stretch the distance, the Ukrainian FPVs had to drive their motors close to maximum output. The remaining battery power was enough to keep them in the air for only about 45 more seconds, but they had no intention of reaching the target. After 30 seconds of pursuit, once the Russian interceptor UAVs had fully left their position protecting the bridge, the Ukrainian FPV group suddenly slowed down, made a sharp 180 turn, and charged back in the opposite direction. The distance between the two formations closed at 260 miles per hour. The Russians had only 2 seconds to realize that the targets they were hunting had turned into suicide UAVs. The collisions happened one after another. Fireballs flashed in the air as the 7-pound warheads of the Ukrainian FPVs detonated, pulling the Russian interceptor UAVs into clouds of fragments. Within only a few seconds, almost both formations disappeared from the sky. From the perspective of the Russian air defense crew, the interception seemed to be over, but they had missed the second group. The FPVs they believed had run out of energy were still silently flying along the embankment at an altitude of only 3 feet. At that height, they could manage only 30 miles per hour using the slope bushes and broken concrete slabs to stay hidden from view. The entire aerial fight lasted 45 seconds. But to survive and deceive, the Russian interceptor UAVs, the remaining FPV group, had burned through almost all of its reserve power. The batteries were down to just 6%. Meanwhile, 2/3 of the Russian convoy had already crossed the bridge. The fuel tankers were still lined up in a long column, slowly crawling over broken concrete slabs and warped steel beams. Ukraine was running out of time. As the distance to the bridge dropped to 500 yards, the FPVs left the cover of the embankment, climbed to 45 feet, and began the final attack phase at 120 miles per hour. Their motors were pushed to maximum output, turning the little electricity they had left into speed. But at this battery level, they had only enough power to fly straight into the target. One sharp turn, one climb, or one evasive move could drop the voltage below the operating limit. If that happened, the motors would stop spinning before the UAVs could reach the convoy. And the Russians were ready for that. The escort soldiers immediately raised Pichkal Pro and Stupor electromagnetic guns from their fighting positions. They fired directional jamming beams at the UAVs, disrupting control links and interfering with navigation systems. In theory, Pichkal Pro can affect targets at a range of 5 miles. But in real combat, its strongest effect comes when the soldier can actually see the UAV point the antenna directly at it and hold the jamming beam on target long enough. The lead FPV was locked first. The image on the screen froze. Control data disappeared. The UAV banked hard to the left, lost altitude, and crashed beside the road surface. But the drones behind it did not stop. The moment they detected that the link to the operator had been cut, their computer vision modules automatically switched into autonomous AI mode. The cameras began searching for the outline of the bridge, the shapes of the fuel tankers, and the large heat signatures from running engines. The AI locked onto the target. From that moment on, the electromagnetic guns could cut the signal from the ground, but they could no longer order the FPVs to turn back. The drones already knew where they had to strike. The Russian soldiers immediately shifted to the final and oldest method of defense and warfare, infantry weapons from the escort vehicles. Russian troops moved close to the bridge, railing, raised their AK-74S into the sky, and poured 45mm rounds into the FPV's flight path. They were not trying to hit each drone with precision. Their goal was to create a wall of bullets directly in front of the incoming formation. At the rear of the convoy, soldiers carrying vapor, 12 shotguns were already waiting. Buckshot spread outward into a cloud of lead, far more effective against small, fast targets that only appeared in the sights for a few seconds. At a distance of 150 yards, the first 75 rounds tore through the formation. 3 rounds hit. One sliced into the propeller of the FPV on the left, deforming one blade. Lift became unbalanced, causing the UAV to tilt immediately to one side, while the flight controller had to keep increasing power to the other 3 motors just to keep it in the air. The second round punched through the carbon fiber frame of the drone behind it. The structure did not break apart completely, but the entire UAV began shaking violently at high speed. The third round was more dangerous. It pierced the battery casing. Voltage began dropping from 14.4 to 13.1 within 2 seconds. The damaged cells could no longer supply enough current while the motors were running at maximum output. The camera image darkened, propeller speed began to fall, and altitude started bleeding away foot by foot. Now the FPV swarm had only a few seconds left before losing flight capability entirely. But ahead of them, the Russian fuel tankers were close enough for the AI to see the convoy on the bridge. The 3 remaining FPVs were the final sparks of hope for the attack. Russian soldiers kept firing, but the very bullets that damaged the drones made their flight paths harder to predict. One was banking hard to the left, the second kept jerking upward and dropping back down, and the last was shaking violently because its battery casing had been pierced. None of them could still hold a stable trajectory for the Russian shooters to lead properly. Inside each drone, the flight controller and AI module kept redistributing thrust between the 3 motors that were still functioning, trying to keep balance as battery voltage continued to fall. The distance was down to just 100 yards. Battery power remained at 6%. The AI pushed all remaining energy into one final burst of speed. The 3 FPVs surged forward at 200 per second. Even as the propellers began losing thrust, when voltage dropped below the operating limit, inertia kept pulling them toward the target. In just 0.5 seconds, they crossed the final 100 yards, skimmed over the heads of the Russian soldiers, and dropped toward the fuel convoy below. The shooters immediately stopped firing because a single stray round could punch into the fuel tanks beneath them. Knowing their last chance had vanished, they turned and tried to escape the area. At exactly 1:42 hours local time, the first FPV slammed into the side of a tanker near the middle of the bridge. Its 7-pound-shaped charge warhead detonated. The metal jet punched through the tank shell in an instant, releasing fuel into a dense mist. Less than 1 second later, the fuel vapor mixed with flame and ignited. A 60 feet wide fireball expanded above the bridge deck. temperatures in the central burn zone could exceed 1,000-degree warping thin steel panels and burning the paint off nearby vehicles. A column of fire shot more than 100 feet into the air, pulling a rolling cloud of black smoke 400 feet above the bridge. The pressure wave traveled along the bridge deck, shattering windshields and blasting loose chunks of already cracked concrete. The tanker that had been hit tilted hard, slammed into the side of the bridge, and blocked the entire passage. But before the first explosion had even finished, the second FPV arrived. It dropped into the section where several tankers were squeezed together on the narrow span. The warhead detonated near the underside of one vehicle, tearing open the tank and spraying burning fuel onto two others beside it. The flames spread along the line of vehicles within seconds. The tankers trapped in the middle of the bridge no longer had enough room to move forward or turn around. Tires began bursting one after another from the heat. Valves and fuel lines on the tank started to fail, releasing more fuel vapor into the fire. Each time another compartment ruptured, a new column of flame erupted nearly 60 feet into the air. Some vehicles at the rear of the convoy managed to reverse. They collided with one another, slipped away from the intact part of the road, and hurriedly scattered to both sides to escape the heat zone. The third FPV was still flying. It had lost almost all electrical power, but the AI still kept the target outline inside the camera frame. On the far side of the bridge, the tankers that had just crossed had not yet accelerated and were still bunched tightly together. The UAV lowered its nose. At a distance of 50 yards, the final motor stopped spinning, but inertia was enough. The FPV slammed into the vehicle in the middle of the group that had just cleared the bridge. The warhead punched through the tank, creating a 60-pound per square inch pressure zone inside before fuel was forced outward and ignited. The third explosion spread into the closely packed vehicles nearby. A chain of deep, muffled blasts followed less than a second apart. Metal plates were ripped from the tank bodies and thrown dozens of meters away. Fire spilled across the road, engulfing the vehicles that had not escaped the formation in time. Only the lead vehicles still had a chance. Their drivers floored the pedals, pushed their engines to maximum output, and fled from the bridge as columns of black smoke rose behind them. In less than 10 seconds, 3 FPVs that could barely still fly struck the 3 most critical points: the middle of the bridge, the entrance, and the exit on the far side. The convoy was completely split apart. The vehicles at the front were forced to accelerate and flee. The vehicles behind could no longer move forward, and the fuel tankers trapped on the bridge were quickly pulled into a chain of fire and secondary explosions. But the real consequence was not only the number of vehicles burned. When a fuel transport route is blocked, the entire logistics system behind it begins to slow down. Fuel meant for tanks, armored vehicles, artillery, and supply trucks in Crimea and Zaporizhia cannot arrive on time. A mechanized force without fuel loses mobility, and once it can no longer move, its expensive combat vehicles become fixed targets on the battlefield. In Crimea, limited supply forces Russia to prioritize fuel for the military and emergency vehicles. Civilians and private businesses face rising fuel prices, long lines at gas stations, and the risk of power outages when plants lack the fuel needed to operate. Strategically, this is what Ukraine is truly aiming for. Kiev does not need to launch a direct assault on the peninsula. Instead, it strikes road routes, rail lines, and maritime transport corridors, one by one gradually turning Crimea from a military fortress into an area increasingly isolated from its logistics network. This is also the power of asymmetric warfare, using UAVs that cost only a few thousand to destroy tankers, fuel, and supply chains worth millions. The 3 FPVs did not have enough energy to return, but they had enough to shut down the bridge, split the convoy, and force the entire logistics system behind it to pay the price.